This underwater footage, taken by the Oregon Department of Fish and Wildlife using a robotic submersible, shows a healthy reef near Cape Perpetua. Under normal conditions, these nearshore waters are home to a productive ecosystem of fish, invertebrates, and plants. This footage was taken at the same reef during a hypoxic event. There are no fishes in the reef because they have moved away to find oxygen. The slower moving animals cannot leave and suffocate. The dead zone leaves a change.
Each spring, our coast is dominated by winds that blow from the north to the south. This wind is the engine behind ocean currents that move cold water up from the deep ocean to the coast. The upwelled water is naturally low in oxygen. This upwelling can be seen from space as a band of cold water that forms along the coast. Upwelling currents also bring nutrients to the surface of the ocean, where they fuel the growth of microscopic plants called phytoplankton. Phytoplankton bloom and fuel a productive food web in the upper ocean. The phytoplankton eventually sink toward the seafloor, where they decompose, using up oxygen in a layer of water that has less oxygen to begin with. This combination can give us dead zones that can envelop much of the coastal ocean.
Well, part of the reason there's a problem on the Oregon coast is because we've got this huge Columbia River kind of feeding out. And that river is kind of traveling from all over the place. I mean, it's not just picking up water from some of the rivers like the Willamette in Oregon, but it starts in Washington, which is very agricultural, particularly the lands that it's flowing through. So it's picking up a lot of nutrients. And once it gets out there, it's causing a big buildup of those nutrients, which kind of lead to the whole hypoxia idea. Well, you got to think about what starts a dead zone. Dead zones are started for a lot of different reasons, but a big piece of it is those nutrients coming in, particularly from urban areas with, sewage. And then you've got nutrients coming off agricultural fields. So one of the biggest things you can probably do is just conserve your water. I mean, it's hard to conserve your waste. And then just encourage farm practices that don't tend to use liquid fertilizers like the chemical industrial fertilizers. Using things like manure. Normally organic farms use those type of fertilizers. So if you can encourage those practices and more sustainable ways of growing, then it can really help. That it's going to get worse because our demands on agriculture are getting bigger and bigger as we get more people, as we're exporting more food. We're putting a lot more demand on our land, and we're expected to grow faster, grow more, and you need fertilizer to help do that when you're putting those sort of pressures on the land. And so I think it's going to get, unfortunately, a little bit worse. And with what's going on with global climate change and the whole way that it's kind of interfering with the flow of water and how it overturns, I think it's going to get even worse. How does a dead zone form? You know this, Maddie. There's a whole cycle. Hypoxia, well, dead zones are what result when an aquatic system goes through a hypoxic stage. And hypoxia is the last piece in a long chain of events. Eutrophication starts when there's a nutrient release. This is normally how this happens, but it can happen with water cycling. But what happens is basically there's a huge nutrient surge into a water body, and this can be a river, this can be a lake, or it could be the ocean. And basically what happens is, plants on the land love fertilizer just as much as plants in the water love fertilizer. And algae, along with other aquatic plants, basically grow and grow and grow because they've got all these nice nutrients. And basically what happens is, they grow, they die, and then where the oxygen starts getting depleted is when they die, the bacteria that are in the water, those organisms that break down and decompose that material, start consuming the oxygen. And so basically they literally suck all the oxygen out of the water if there's enough decomposing stuff happening. So that's one way that a hypoxic zone can happen. Another way is the same sort of idea. What happens in the ocean, deep in the ocean, stuff that's floating around on top of the ocean, where most of the biological life is, towards the surface, that eventually gets down onto the floor of the ocean. And what naturally happens is there's a sort of cycling of water, hot air rises. Well, the same sort of concept happens with hot water. Hot water rises, cold water falls, and you have this sort of natural cycling. Well, with global warming coming along, it's changing weather patterns, and it's tending to cycle water at a different sort of rate, and so we're seeing this upwelling of cold, oxygen-poor water because all the decomposition is going down on the bottom. All that water with little oxygen kind of cycling towards the surface, and all that surface life is dependent on nice amounts of oxygen. If it's not there you've got another way to get to a dead zone. From what I understand, it's just a lot of nutrients. It all relates back to our burden on the land with agriculture. Just more fertilizers, more nutrients. Also livestock. Think about how much livestock waste we're using.
I can put it in there.
Livestock! Eat less meat, less waste. Oh, I forgot about that. So livestock waste as well. We're so dependent on agriculture, and agriculture has become so big in the U.S., particularly over the last 50 years. And the U.S. isn't the only place. Any place that's agriculture and uses, industrialized fertilizers that tend to be a little bit easier for the water to take with it when it rains, easier for runoff to kind of take it. That and livestock waste. People are in more urban areas. Urban areas tend to be near the oceans and bodies of water. So it makes sense. As our population gets bigger, we got more demand on the land and more poop. There are a lot of people out there that make some really good statements, a lot of good justifications for the connection. Basically, as global warming kind of ramps up here, the land is getting drier and hotter. Well, as a natural way for the Earth to regulate its temperature, you get more winds, you get more rain, those sort of things. And so what's happening is, as the land gets dried out, because all this heat and stuff, the winds are becoming stronger. And as the winds become stronger, they help with that sort of upwelling idea that I was talking about earlier, the upwelling of cold and warm water kind of cycling around. It's basically sort of helping push that. I mean, winds are the Earth's air conditioner. So you've got sort of cool air on top, warm air on top, starts to cycling. So the hotter the land gets, basically the more of this upwelling and cycling, this mixing of nutrient-rich water or oxygen-depleted water kind of going in and starting to cycle more and more and more. From what I understand, most of the coast of Oregon is seeing these hypoxic areas, and most of the coast of the U.S., particularly West Coast, East Coast sort of areas, and the Gulf.